Welcome back to Outward Home Learning. The subject that we're looking at today is computer science, and the topic for this session is units and why binary. So we're going to go over to Mr. Halton, who's going to explain a bit about units and why we use binary in a computer system, and then you're going to answer some questions. Over to you, sir.
Why binary? Why do computers even use binary? It's kind of a curious system, isn't it, where they're stuck in either a 1 or a 0 and they have to use loads of ones and zeros to get things done. And the answer is because of these things called transistors, which are little electronic components which act like switches. So if you have a look at like a light switch on a wall next to you, then that is basically what a computer gets to use. And a switch has only got two states, hasn't it? It's either going to be on, so your light's going to be on, or it's going to be off. And that can be represented either as the words on or off, or for computers it's easier, on is a 1 and off is 0. So you might think, okay, I've got transistors in my computer, they can be 1 and a 0, but I don't quite get how they can be mapped to like a video like you're watching now, or the computer game that I've recently been playing. And that's because computers don't just have a few transistors, they have got billions of them. And then they are switching either on or off also billions of times a second. So when you're dealing with billions of switches which can switch states billions of times a second, then you start thinking like, okay, well maybe I can have a switch that can represent if a pixel on a screen, a little dot on the screen is a particular colour, because I've got so many of them and they can change states so many times. And so that's why computers use binary to begin with, because they all use transistors and they are either on or they are off.
So now you've heard a bit from Mr. Halton about why computers use binary and how the unit structure works. You're now going to answer some questions, or you're now going to reorder some items. You're going to look at the unit and the description, and you're going to make sure that the unit matches the description given. So you're going to get 10 minutes to do that, and then we'll review your answers. Off you go. Okay, time up. So we're going to go over to Mr. Barnes, who will review your answers.
Okay, so let's have a look at this unit sorting task. There's two things we've got to do here. First of all, we've got to get the units in order, smallest to largest, and then we've got to match the correct description to them. Okay, so first of all, we're going to get these in order. So the smallest unit we've got is a bit. I'm just going to place it here for now. Okay, and a bit, and I'm going to shuffle these around at the same time. I'm going to do the descriptions as well. And a bit is very simply a single 0 or 1. So I'm just going to put that up there. Okay. After a bit, we have a nibble. A nibble is 4 bits. Okay, so a nibble is 4 bits, 4 zeros or 1s. After our nibble, we've then got a byte. A byte is 8 bits, which is also 2 nibbles. Next up, after a byte, we have kilobyte. And a kilobyte is 1000 bytes. You may get it referred to as 1024, but for the purpose of this GCSE, let's use 1000 because it makes it easier for our multipliers when we don't have a calculator. Next up, after a kilobyte, we have a megabyte. And guess what? In a megabyte, we have 1000 kilobytes. And after megabyte, we've got gigabytes. Now we're getting into territory we know more of. And in a gigabyte, we have 1000 megabytes. And after megabyte, we've got terabyte, which is 1000 gigabytes. And after terabyte, we've got petabyte, which is 1000 terabytes. Okay, so notice once you get past a byte, everything's in multiples of 1000, and that's really important. So you can then say how many kilobytes in 1 gigabyte, and you simply do 1000 times 1000. So there we go.
So now you've done an activity and you've heard from Mr. Holton. We're going to move over to an exam question. So this is where you're going to try your very hardest to answer these questions as accurately as possible based on what you know. Time up. So over to Mr. Barnes. Please make sure you mark your answers.
Okay, so let's have a little look at these exam questions then. So we've got a computer has a hard disk of 2 terabytes. How much is this in gigabytes? So remember, we go kilobytes, megabytes, gigabytes, terabytes. Okay, terabytes being the biggest, and we're working in multiples of 1,000. So if we've got 2 terabytes, we've got 2 times 1,000 because we're going down the scale once. Therefore, we've got 2,000 gigabytes. Okay, let's have a look at the mark scheme then. Move this up slightly. So it says multiply by 1,000. Well, we've done that. And we've got our answer, 2,000 gigabytes for 2 marks. Okay, let's have a look at the next one then. So we've got Bob's computer has 512 kilobytes of ROM and 8 gigabytes of RAM. State how many bytes are in a kilobyte and a gigabyte. So we've got, it goes byte and then kilobyte, megabyte, gigabyte. Okay, so again we're working in multiples of 1,000. So we've got 1,000 bytes in 1 kilobyte. Okay, now to get to a gigabyte, it's a little bit more challenging. We have to do 1,000 times 1,000 times 1,000. So 1,000 times 1,000 times 1,000. Okay, the easy way to work out what the answer to that is, count up the number of zeros and put a 1 in front of it. So we've got 9 zeros. 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's move this up very slightly and let's have a look at the mark scheme again. So just down the bottom here we've got 1 kilobyte equals 1,000 bytes, or 1,024, so obviously we're going to go for 1,000 because it's easier. So 1 gigabyte is 1,000 times 1,000 times 1,000, which is 1 billion. 2 marks. Okay, final question then. Explain why computers represent data in binary form. 2 marks. Okay, so to answer this question we need to say what computers are made up of and why that means they can only understand binary. So we know computers are made up of switches. Switches have 2 states, on or off, which is represented in binary using a 1 or a 0. Okay, so we've got 2 points. So we've made our point there, what they're made up of, switches, and then we said why. Why does that mean they have to be in binary form? So let's all move that up slightly, and then let's have a look at the mark scheme. So we've got here, computers consist of transistors, switches, logic circuits or gates. So we've mentioned switches, so that's 1 mark, which can only have 2 values, on or off, 2 marks. Okay, which I have then gone on to explain why that means binary. So I've probably gone a little bit above and beyond there. Okay, but either way, 2 marks.
And for GCSE, that's everything you need to know about units and why we use binary in a computer system.